Hello, sir. This is my explanation for my question. All right. So, if 20 milliliters of zero point 0.2 moles per liter of formic acid is titrated with 0.15 moles per liter of potassium hydroxide, determine the pH after 5 milliliters of potassium hydroxide has been added. So, first, we obviously want to write out a neutralization reaction, which will help us later find the amount of moles required. And we can see immediately right here, all the H's are not, I guess, dissociated. And so we understand that the formic acid is a weak acid, which will later help us. So now we would want to find the excess amount of reactants. And so we'll use the formula of N equals to concentration times volume. And we will found that the amount of acid before mixing is 4.0 times 10 to the power negative 3 moles, and the amount of base is 7.5 times 10 to the power negative 4 moles. And the reason why I want to find the amount of excess reactant is simply because the amount of excess reactant will help us find the amount of pH, as the other reactants that are not excess are already mixed or neutralized with the base, which produced water. We want to find these. So simply, if we look at step one, when we wrote out the reaction, we see that it's just 1 mole per 1 mole. So to find X amount of moles needed for the acid to react with the base is 7.5 times 10 to the power negative 4 moles. So the amount of X is reactant simple. Use the initial and minus it with the one that has been used to mix with the base. And we would have 3.25 times 10 to the power of negative 3 moles. Now we found the amount of excess acid, we will use an ice table to find the concentration and the results to plug into equation to solve for X. But before that, obviously, we have to find the concentration. And so we use our new found moles, excess moles divided by the total amount of volume after mixing, which is 0.025 liters. And we'll have 0.13 moles per liter as our new uh, concentration. As we said above, formic acid is a weak acid, so equilibrium must be considered. So as we write out this equation right here, we can see that it produces protons. So this will be what we use to solve for our pH. And this formic ions will be the X amount of moles that is mixed with the base divided by the total amount of volume added after, because since it's at equilibrium, this is technically the excess amount that we're trying to calculate for the pH plus the amount of acid that is mixed up with the base. And so we will have 0.13 moles per liter for the initial for formic acid, 0.03 moles per liter for the formic ions, and 0. Minus x plus x because there is no coefficient, it's just 1. And we'll come to the conclusion that these are the values. Now, as we plug it in, first we know that the K value of formic acid, the weak acid, is 1.8 times 10 to the power negative 4. We just know that, it's given. So we will plug into this equation right here. Ka, obviously, if we want to calculate for Ka, simply the opposite side times together divided by the acid, and we'll get this equation right here. And so we plug in the values we got from the ice table in here, and we will have this equation. But that equation is not perfect square, and it looks a little too complicated. So simply we just grab the concentration divided by K value. And is it greater than 100? We could consider the minus X negligible. And after we plug it in, concentration of the leftover divided by the K value, we get 722, which is a lot greater than 100. So minus X is negligible. And we can consider that these are true. So after we plug in the new equation, we will find X is 7.8 times 10 to the power of negative 4. And so now we want to check for the 5% rule to see if it's really valid. And the 5% rule is simple. X, which is that, divided by initial concentration times 100%. And we find that it is less than 5%, which is 0.6%. And now people might ask, why don't we use the zero point 0.2 moles per liter? Because if we're asking for the initial concentration, isn't this the initial concentration? Well, that's true, but after mixing up with some base, some acid and the base were mixed together, and so the equilibrium will no longer be at zero point 0.2 moles for moles per liter for the initial one, and so we later found out that 0.13 was now the new concentration. And so we know that is all true, so we plug in the x value, and if we look at the ice table, the x value is simply the h, as it initially was 0, now it's x. Now we plug into the pH with the formula of negative log h, and we would have 3.11 as our pH.